We're solving problem 11 from the 2025 AIME2. Let S be the set of vertices of a regular 24gon. Find the number of ways to draw 12 segments of equal lengths so that each vertex in S is an endpoint of exactly one of the 12 segments. So for this problem, it's going to require pretty complicated insights for the solution at least. So what we can do is we have this length D, we have a length D, right? Such that you have a vertex and it connects to another vertex D units away. Therefore, you basically want to just sum the lengths D. D is 1 to 12, right? Basically. Now what we can do is we can let all the lengths of the 24gon be just set to 0, 1, all the way to 23 mod 24. Now notice, for any chord of equal length, we're going to have the pair V, V plus D, where D is greater than or equal to 1 and less than or equal to 12. Then we have G, a variable G, where G is, we let G be the GCD of 24 and this length D, right? And for this length G, we're also going to have to incorporate another point M, where M is G disjoint cycles away, and the length is 24 over G. Now, the reason why I had this complex table setting up is because, frankly, I don't want to solve it during the problem because it is going to be really redundant. But once we've basically clarified M is 24 over G, G is GCD of 24 and D is 1 to 12, we can start solving. So, of course, we want to use your logic. If we have C sub M disjoint cycles, if we have 0 for n of D, 0 solutions. If M is odd, we have 1 if M is equal to 2, and 2 if M is an even number greater than or equal to 4. Thus, we have n sub D, where we basically just want to sum 0 if M is odd, the ones if M is equal to 2, I'll just write 2, and 2 to the power of G for M is even and greater than or equal to 4. Hence, we can start plugging in the values of D. I like to think of this as sort of a process, right? Say you have D is equal to 1. And the 1 goes into the G, and the GCD of 24 and 1 is 1, and then that 1 gets plugged into here, which is 20, and 24 over 1 is 24. So we know that M is an even integer greater than or equal to 4, so you have 2 to the power of 1, which is 2 solutions. So you can keep on doing this redundant process until you have all of them solved, even D is equal to 12, where you then want to basically just sum up all of these numbers. And once you sum up all these numbers, 2, 4, 8, 16, 2, 64, all of that, you will get that the total sum of all these bottom numbers, again, is going to be 113. And 113 is going to be our answer for this problem.